for coming and listening to my talk. As Rachel said, I'm a software QA manager with 3D Systems, and I managed to get my background showing there. Hopefully that says 3D Systems up there. Part of my role is really to enable the team to make sure that they have everything that they need to do their job. We test, 3D Systems makes 3D printers, and as well as the software that allows people to visualize the objects to send to the 3D printers. But fundamentally, my team is testing the software on the printer, and we are testing the whole system. And some people I know from a software or a web application background, testing a system is just maybe a foreign concept, but we do a lot of embedded systems work, as well as obviously we're looking at the whole UI, what the customer's experiencing. So we have a lot of moving parts within our test protocols, but we really are testing the full system. And this talk came about because some of our requirements that were coming down, we like to go back at the end of the project and say, you know, here's the requirement, here's the stories that came from that requirement, here's the test cases that came from that requirement, and here's the evidence of testing to show that we actually met that requirement. And it's just all of our cross matrices going backwards to make sure that we've actually checked all of our requirements off in the first place. And this came about because we were like, we don't know if we actually tested this requirement. So we're like, oh, okay, well, let's break this down and let's see what we come out of it. And really what came out of it was the fact that we don't have enough information when we get handed some of these requirements to actually say, yes, we've tested it, or know what to test. So typical requirements gathering, for at least for our systems, and I'm sure it's true for a lot of your other systems as well, you get input from customers for new technology, and as well as the sales team to make sure you have a competitive advantage. And then you've also got our applications team, which are dealing with the customers. They're working with them one-on-one or with a research group and saying, hey, we need something that does this type of feature, or we need a behavior that looks like this. Some of those really do need different software or different processes or things like that. But there's a whole load of needs from the product's perspective, but nowhere in here is there a need from a building the product or the downstream team's perspectives. So as I say, this is our traditional requirements gathering. And sometimes in all of these pieces that we get put together, we end up with untestable requirements. And really, it's hard for us to say, what's a success in some of these requirements? Sometimes we get that requirement to make it faster, make it 20% faster. And I'll look deeper into that. But the first question that comes to my mind when I'm seeing this requirement is 20% faster than what? 20% faster in what type of conditions? So again, a lack of the baseline metrics and giving us an understanding of what we're measuring against to show that evidence of testing and to show that we've met that requirement coming back to do our PVM. And we also get some very broad requests. Use plain English in your error messages. And plain English is, you know, I'm from England, okay? I get it. I get plain English. I understand plain English. But in an engineering world, development may say, oh, the calibration failed. And you go and put that on an error message to say the calibration failed. And you put that in a production environment, and the customer or the operator who's using the printer says, great, calibration failed. What do I do? What does that mean? And really what that requirement early on was saying, give us enough information on these error messages so that we know what to do next. It wasn't just give plain English. It was really give us all of the steps that we need to do in order to recover, or whatever the follow-on processes need to be from this error. So again, that's that level of really getting into the nitty-gritty of some of those requirements. But those poor requirements or low detailed requirements really gives the QA team problems. As I say, we talk about guesstimating for our baseline metrics. Sure, we have a standard set of prints and stuff that we run every time. I'm sure everybody has some maybe it's a disk usage metric that somebody uses for some of their tools. Maybe it's a speed access or a memory usage. We have a lot of those baselines that we know, but maybe it's not from something that the last customer release was or something like that. So again, give us that understanding. That's our requirement. We need to know these details so that we can go back and say, yes, we actually showed you a 20% improvement or whatever that was. Inconsistent understanding for validating a requirement. This has been a bane of my life for a long time. It's like the requirement said X, so we thought we tested for X, and actually the requirement said X and meant Y, and we were way off what we were supposed to be validating. So it's just really trying to make sure that we have all of the understanding and the right tools in place to be able to do that. And then from our perspective, obviously, we're going to go back and verify that, our test plan had all the requirements in it that we needed, and that we have the evidence of testing to go back and prove that requirement. If we don't know quite what that requirement is or what all of those details are, we have some evidence. Sure, we ran some testing, but really, does it show proof of evidence of that requirement? So let's just step down into a very simple detail of a requirement. So you can see really where bringing in the QA team and asking these questions early on pushes a whole load of information back upstream to say, yeah, there's a lot more detail that we need here. We need to understand these things. We have some testing needs to say, hey, give us some of these details. So we had a very simple requirement to show completed job details on the UI. So completed job, obviously, once a printer's running, starts a job, it finishes a job. It's like what it said, show completed job details on the UI. Okay, so most of our printers have a fairly nice, it's a tablet-sized UI. There's a lot of space on there. We can put a lot of stuff in there. But my question came back, exactly what job details do you need? They started out with a job name, the job start time, and job end time. Okay, great. Okay, job name, that's pretty simple. Okay, we got that. Job start time. What does start time really, really mean? So for some of our printers, we have some preparation time that needs to take place. We have a whole load of calibrations, or some things need to move into certain home positions, or we need to make sure that the material is warm. We need to make sure that certain cleanup routines have taken place. So before we actually start putting material down on the plate or start firing the laser to cure the material, we need to have some preparation time. Is that included in the job start time? Because to us, job starts when you start putting material down or when you start curing material with the laser. That's a job start. This stuff before is preparation. It's a terminology thing, but when a customer's saying job start, I think what they were really looking for is from the time I press the button to the time I can get the job out of the printer. So start time has some nebulous meaning to it. Likewise, in job end time, some of our SLS printers, the laser sintering printers, they have a powder bed that gets super hot. We're sintering at 300 degrees C. That's pretty hot. You can't take it out once the job is finished. So there's some cool down time needed. Is that included in the job end time? Maybe, maybe not. So, and likewise for the SLA printers, we have some very sludgy material that when you bring the platform up out of the resin bed, it needs to drain because it's kind of like a molasses type of thickness. Some of them are really bad. So you don't want to go and take the plate off, otherwise you're going to be dripping all of that lovely material all over the place. So we want to make sure that it drains for some amount of time. And obviously draining depends on the height of the parts or a whole load of other stuff. But there's some average draining times that we have. So does the job end time include that level of detail or not? Other things that are pertinent to the job, the material used, as well as how much material was used. And then we come down to the question of where to show this information. Do we show it on the queue? Do we show it on the build report? Do we show it on the status? Status screen is just like the home screen that we have on all of the printers. But on the queue, we have a list of the completed jobs. Do we want to go and select an information bar on this single line job data to get more information? This requirement doesn't say anything about that. So it's really digging down into these and saying, hey, there's more details here. Sure, we can show the job name, a start time, and end time and material used when on status screen. But is that really what you're looking for? There's more to dig into this. Sorry, I forgot to say at the beginning, by the way, if you have any questions, please just raise your hand. I'm sure there's a mechanism to do this in here. I haven't quite worked out what it is, but I will endeavor to answer any questions that come up. So please do jump in. One of the locations for us, one of our sources of evidence of testing is really down in the log files. The log files from engineering perspective have been there and have been a tool for them to use for a long time. But the log files were really designed from the beginning for the engineers. And they really didn't spend a lot of time thinking about what QA could get out of this, what our testing data was in there, what can we use this for. And sometimes there's some really good information in there, some hidden nuggets of information. Searching for log files for material usage or for job data, for start times, for end times, for warm-up times, all of that really is in there, but it's hidden and it's kind of not always very, oh, shoot, I need to move around. The lights turned off in this room. Sorry. It's not very productive. It's not very obvious some of the times. So sometimes we end up writing tools to get into that data, to find that data. And that's great. We have very capable scripting, a team that can write the scripts for us to pull all that information out. But then log files change from release to release, or we get an engineer that really likes a date format that's slightly different from somebody else, or we like an engineer that likes to put mixed case and camel case in there, and we're looking for some comparison of a string because we knew that was what it always was. So those log files change on a release to release basis. So there's a requirement from the QA team to the engineering team, never mind a requirement from the marketing team. This is a requirement just on the projects themselves. If your log files change, that's fine, but tell us, right? If there's some formatting in there that changed, let us know, because we have a requirement. These tools should work from release to release. So please keep us in the loop on something like that. I'm sure there's a few people that are nodding their heads in agreement, trying to work with the frustration of things changing underneath them when they weren't aware of that. Let's look at that job data. So in the log files, obviously with the job name and the material used, total layers printed, that's a really good information. That's a good metric. It's like, your miles per gallon, right? We have a lot of maintenance that needs to take place. And like an odometer on a car, you change your oil every 5,000 miles. We tend to do it on layers printed. So that's a really good one for us. And also the success of the job. It would be good if we know if it passed or failed, if it completed, if it aborted by the user, if it aborted by the printer. So again, some more information in there. And looking at that timing data, digging down into the timing data, those log files really do have a lot of information from when things are thermally ready, when all the materials checks are made, when the surface of the resin is leveled out and smooth, so we can actually start with a clean, flat surface for the laser to start curing the material. And then once the job is started, those log files have a lot more information in there for us to use. The number of layers that, whether you're printing the part or the support layers, whether you're the rates that you're firing layers, a whole load of information, technical information that we could find in there. And then once the job's completed, give us the timing data for that as well, and the move to drain and the cool down, how much time that's going to take, and also potentially when the job was removed. So there's a whole load of data that we can find in these log files. But again, it's our requirement back to the engineering team or back to the design team to say, hey, give us this information in these log files, please. And don't hide it. Make it obvious so that we can use it and see it. So coming back down to those testing requirements, there's a whole load of stuff, right? This is just a summary of what we started out with, that very one simple requirement to put, have the job completed data on the UI. And this is something that came out of really digging into all of that simple requirement. The job name, the start time, when the user presses play. That's what we call the initial start time, when the user presses the play or the start button for the job. The throughput, throughout the job, obviously we want those layers printed. And then at the end of the job name, the completion abort. Oh, this is a big one. Okay. Duration of the job. Very simple request, right? Tell me how long it took. I won't tell you how long it took me to get this request into the team to say, can you please give us a summary of the job at the end? Very often we got, especially on some of our legacy printers, all we got was, job done, that's it, job done. Some of these jobs take 3 or 4 days. So you've got a lot of log files to go through. And remembering the job name and the start and the job name at the end is like, is this the same end? I don't know. Anyway, long story short, I begged and begged and begged and said, please, will you do the math and tell me how long the job took so that I don't have to do the math in my head or go back and search through all of the log files to find that start information. And then of the total number of layers printed. take a look at another type of requirement that we have, which is those baseline metrics. And I'm sure everybody's had some form of metric to go quicker, to be quicker than what they currently are. For us, quicker than what is a really good question, because we have some customers out there that take a long time to update to newer versions. So it's very easy for us to say that 2 years ago, a build time of a similar job would take, 2 hours, and now it takes, an hour. We've 50% improvement. But if we did that from 6 months ago, I don't think we could say it was 50%. So again, it's really important to understand what you're measuring against when you say 20% quicker. Previous customer release is often the response, and that's fine, but at least we know what that baseline is. And then for us, is it 20% on average or on 20% on every single job? And if you're averaging, are we averaging across the short jobs, the tall jobs, the long jobs? All of those different types of metrics that you can have on there is, what are you averaging across? So what's your test set is what we're really asking here. And likewise, is it 20% on every job and all materials? Like I said, some of those materials are really sludgy. It takes a long time for the resin to come back to the top of the surface when you've done a pump to get another layer of material in there. So all materials, do we need to be 20% quicker on all materials? And then all the dimensions of the jobs. Again, it's coming down to that detail of what is that test set? What are you really trying to prove as your requirement so that we can show that we've met it? So the baseline metrics, specifying the sets of jobs, the material, and the baseline really does give us that ability to then report back to say, yes, here is the real data for the quantitative data of what we tested, and here's the improvement that we made. From an engineering perspective, it's easy for them to say, oh, this part of the process we can speed up 20%. But when you take that part of the process, maybe it's only 2% of the whole thing. Is that a 20% improvement across everything? Or is it just a very small improvement generally across the whole scope of the print itself? So it's very easy for engineering to dig down and say, yes, I can make this 20%. I can make a 20% speed improvement here. But from the QA perspective, again, we're looking at testing that full system. And the customer's perspective is very much, I start the job, I end the job, I get my parts out of the printer. And that's really what that 20% speed, when you go to a marketing document and say, yes, we made an improvement, we can say, yes, this is where the 20% is. Convenience of testing, I nearly didn't put this in, but I think this is a really important part of understanding what the testing team have to go through in order to do some of the testing that takes place. Efficient testing for us really is, we want to make sure we can get the most of our working hours testing on the systems, and then overnight we'll run our prints. We'll run our testing prints overnight. It's just the way we've always done that and made the most time, unless we're doing split shift work. But typically, we're 8 till 5, 8 till 6, whatever it is, and then within that we're printing overnight. So we have a process in one of our printer families that needs to flush out material from the printer itself, and it has a cleaning material. And the cleaning material for some specific material changes has to sit in the printer for about 12 hours. So that's a lot of sitting doing nothing. Then sometimes we can make that testing run overnight, and sometimes we can't. So I simply asked the team, could we have a shortened countdown timer or a way to shorten the countdown timer that didn't impact the customer's perspective of this? So we're not asking for a debug build or an engineering build. We're asking for a knob that we can turn in a fashion that doesn't impact really fundamentally the code underneath, so that we can run the testing. For our perspective, a printer sitting with cleaning fluid, there's nothing to test, right? We as a QA team are not looking at the quality of the print coming out most of the time. What we're looking at is, do all of the steps in the software take us to the places that they need to go? Do all of the transitions need to take place? So from that perspective, being able to shorten the countdown timer, we know we went into the countdown timer, and we just want to make sure that we come out of it and go into the next state of things. So from that perspective, it was really simple for us to say, hey, can you just give us a countdown timer that we can change, please? And sometimes we could make it 5 minutes. Sometimes we'd make it over lunchtime. So it's a 25, 30-minute countdown timer. Manipulation of the printer states, from our perspective, it's really easy to be able to say, oh, we need to be able to reproduce this error state. Well, okay, that's great. But it takes 4 or 5 different steps to get into that error state, and it's not always predictable. And we want to be able to make sure that we go from the previous state into this error state, and then how we recover from the error state. So we are giving us the engineering tools to jump in and say, okay, let's put the printer into a certain state for us. It's hugely helpful for our testing. But again, it's one of our QA needs that people just didn't think about. The engineering team were like, yeah, we don't know. So again, get that requirement in. It's a requirement for us to be able to test efficiently these states. Material levels as well. Some of our material bottles are huge. It takes a long time to run through a bottle, but you have to go through what a customer scenario would be for an empty bottle, okay? Well, if you've got a print for, 3 kilograms of material, that's a lot of material to get through to get to an empty state. Like, can we just change that and force it to be that state? So again, tips and tricks for getting us into those states allows for our testing. Another very simple one for us, which is really a hardware condition, being able to cover a laser. We call this dry printing. So we want to make sure that the laser is firing because there's certain processes and states that need to happen as part of a laser firing. But we don't always want to have to deal with the build plate, the mess on the build plate, or the fact that we're doing a lot of testing, so we're actually using all the material up. But if we can cover the laser, everything else is working as the system should be intended to. But again, it's a convenience of testing. And for us, it's just a simple hardware cover that goes over the laser. But so many times when we're designing these printers, the engineering team are not thinking about that requirement to be able to cover that laser from a testing perspective. So any questions so far? How am I doing for time? Not too bad. One more side topic really is making sure that we have appropriate hardware and timelines. It sounds like an obvious requirement, but there's many times, I don't know from a web perspective if this is really applicable to this type of testing, but when I remember when there was a big hoo-ha about Firefox not being supported, or Internet Explorer not being supported, or the Internet Explorer being the only one that was supported. From our perspective, we need to make sure that we have the right hardware to be able to test the systems on, that we're testing on customer intent hardware and not somebody's board that they rehack to make sure that the jumpers were correct. I mean, we don't mind doing that early on, but right towards when we're getting towards that production level testing, we should be testing on final hardware. Simulators and emulators are a really big tool for us to make sure that early on we can get through all of our test planning, making sure that our test plans are correct. But again, it's something that people don't think about from a testing perspective. They think about it more from an engineering perspective to make sure that they can look and see if all of their architecture is working as expected, things like that. The toasters, mules, and test beds, those are an interesting scenario. There's a few keywords that we have. Toasters for us are really just a rack of the electronic boards that are in the system without any other hardware on it. So we're truly using the toasters and then emulating what is left of the hardware to be able to run as much of a system as we can. This is where we use a lot of our early UI testing. And it's very helpful from our perspective, but again, it's a need that we have and people just don't get it half the time. It's like, why do the QA team need a toaster? It's like, we can use it for testing, please give it to us. And the mules and test beds, they're just different phrases for different extensions of having additional hardware on. So mules very often are a set of toasters with some mechanical pieces, some motors or some Z-axis, for example. One of our printers that we have, we've just had to change the encoding on one of the Z-axis that we have, where the print plate goes up and down as the resin level is, as the build is growing, the print platform moves up and the part is still being built on the bottom of the resin. So, and the Z-axis is obviously one of those things that has the print plate going up and down. So we had to have some testing, but it was only for the Z-axis. That's all that was changed. So early on, we said, well, just give us the toasters and we'll hang Z-axis off it, and we can do our fixture testing on that. So that's what the mules were. And then the test beds are really an extension of that. Test beds are really early printers, no skins, no doors, very safety conscious, being aware of where things are. But yeah, test beds are from that scenario that way. So obviously the complete system and the schedule dependencies. From a software perspective, we do work very much in a agile environment. We do have sprints, and we do deliver a build at the end of each sprint. However, hardware has their own timeline, and it really is their own timeline because they're waiting 6 weeks for a board spin, or they're waiting for pieces to come in. Oh, sorry, I just saw a chat come up. Rachel, was there something I should be paying attention to in the chat, by the way? I forgot.
Not at this point. I was going to quick time check. We have about 10 minutes left. So if possible, leave a few minutes at the end for questions, but
sure.
Great. Carry on.
Okay, thank you. Let me just jump ahead a little bit then. Let me just finish up the thought about the schedule dependencies. The requirements for us is how many, I'm sure everybody on the QA team has seen this. You really get squished at the end because you're the last people to see the product before it goes out the door. And from our perspective, if hardware is late, release date's here, hardware's late, QA's late, QA gets squished, and it's like, no, we can't do that. So we do try and make sure that we have a functional time, a set time that says, we need this time, regardless of when we get that complete system at the end, we need a certain amount of time to do all of our user acceptance testing and our final rounds of testing. So, but those schedule dependencies always tie in. Couple of points about when to get these requirements in. Obviously, if you can see them at the MRD, when you have that marketing requirements document and reviewing it, look for those red flags. What are the baselines? What does plain English mean? Those types of things. Very often we hear these requirements. We find the requirements and we're too late. We're deep into the testing. And that cannot, that request cannot be handled now. Okay, well, that's fine. File it away and get it into the next one. As part of the sprint planning, understanding what you can do for a story, making sure that you can test that. I don't think we need to go this. Well, I'll skip this one. The MRD review is very obvious, making sure that everybody has that. Engineering response, the engineering team have an opportunity to respond to that marketing requirements document. And from our perspective, this is the typical case. This is where we'll get a lot of our needs in. To say, yes, we must understand what that metric looks like. We've had workshops on error codes to make sure that everybody can give input to what is good and what is bad. And then this is also where we get to explain our emulation and simulation capabilities and needs. Okay. Detailed planning. This should be fairly obvious in the sprint planning. And also then where to document them. JIRA stories as acceptance criteria. Get your own testing JIRA stories in. There's no harm in getting those in, okay? Making sure that you work with the development team and say, hey, I have this need. Get it in as JIRA story. Get an item as work that needs to be done. And then who's identifying these QA requirements? There's a whole load of people who can do this. Obviously, everyone on the QA team. If you have a question because you don't know what to test or why to test it or how to test it, there's probably a piece of information that's missing, and that probably can be transferred back up to there was a loose requirement or a missing requirement. Obviously, as a QA manager, I'm responsible for making sure that we really do get all of our requirements understood and heard. And that comes down to working with the rest of the program team managers, both the technical and the software team managers, and then also just listening in with the development team and poking in at them and saying, hey guys, can we really just get this piece of information in here for us? The log files especially, this is where it works with the development team. So to summarize, I love this slide because to summarize, it was clear that they wanted to test the engine, right? They wanted to test the engine. What they didn't have the requirement for was how they were going to drive it, right? So we are testing the engine here, right? We're testing the engine, but we're driving it with a couple of human people. So anyway, don't get this far with your requirements. Make sure that you understand that testers really do have requirements, and they can dig into them at all levels of this, all levels of the flow, of the process of the project, but document those requirements early on and work with the developers. And that is my presentation. So I will open it up for questions. Thank you, Rachel.
Excellent. Thank you for a great talk, Moira. I see a couple of questions in the chat. And is it all right if I read them out?
Absolutely.
Great. So first from Jessica, when making requests for software changes to support efficient testing, what are some of the ways you've convinced dev resource managers that it's worth the developer time?
Yeah, this is a really good one. It's a time payoff, right? I don't have time now, Okay, but ultimately I'm going to save my time later. And really it's the return on investment, right? We've started to look at what we can do for our efficient UI testing. How can we automate some of this? I don't have spare time. I don't have a spare resource to put on this right now, this investigation right now. But at the same time, I know it's going to save me time down the line. So that's a really tough one. And you have to work that relationship with whoever it is you're trying to say, hey, I need this amount of work done. And until you've done a pilot project, I would almost say, pick a battle, pick a small battle, pick one piece of information that you need and take that through the pilot and say, hey, look, really track how much time you would have done, how much additional time you would have done for testing without this helpful piece of information or without this efficiency, and really take that back and say, look, with this small piece of information, yes, it took the development team 2 weeks to do, but over the testing cycles that we have, we're saving a week every time. And if we've got 4 or 5 testing cycles, it's more than a return on the investment. So it's a really good question. It's always hard. I have a very squeaky wheel and people hate it when I come up and say, but can we just? Or, if we just had done that 3 months ago, we wouldn't be in this situation. So don't be afraid of being a squeaky wheel. Sometimes you might be surprised. People learn to speak up for the QA team eventually. So.
Love that response. And I think we have time for one more quick question. I see one from Angelo here. Does QA get involved in the beginning of the product, even at the product conceptualization timeframe?
So in short, no, unless I invite myself, which I do. So it's QA is still in our processes very much an afterthought. Once we've proven, very often we start with proving technical efficiencies. We need to prove that technically this can be sound, feature can work, this can be done. And the technical investigations, I always like to sit in on some of those results, because then it gets me thinking about, this is a great process, but as we start to develop it, where are the pitfalls from a testing perspective? Where are the efficiencies from a testing perspective? So we don't get in early enough unless I force myself in there. And then when we do, it's like we have really good conversations. So it's not that we're saying, no, we can't do that. Oh my goodness, it's going to take years to test. No. Going in with the attitude of, okay, let's see what we can do. Are there some testing efficiencies that we can bring out from this? So.
Love that. Like a real instance. I heard someone say in another talk yesterday, we're not pulling testing left, we're moving testers left. And it sounds like you are moving yourself left to be that tester in the room, which I think is great. We got to do more of that.
Absolutely.
Any last thoughts from anyone or from you, Moira?
The only thoughts from me is the developers really are our friends, and just get on with the development. Even if you only want to start with a small pieces, start small. Look at those log files. For me, it was the log files that really came out, and we have a host of tools now, and the developers know when they see a requirement from me to say, please make sure these tools work with this version of software. They understand what we're talking about, and they know it. It's just sometimes they don't quite get it in their heads to start with. So start small, and you'll reap the benefits.